Today we're going to be doing the second part of section 3.8, derivatives of inverse trigonometric functions. So I have a question. When does a function fail to have an inverse? When the function is 1-to-1. So derivatives of inverse functions. If f is differentiable at every point of the interval I and dy dx is never 0 on the interval, then f has an inverse and f inverse is differentiable. Question: how could we find the derivative of the inverse of any function? Is there a general rule? Use y equals f inverse of x to begin. Okay, so what we would do is we would have f of y equals x. So then I would find f prime of y times dy dx equals 1. And then I would have dy dx equals 1 over f prime of y. And we know that y is f inverse of x. So I would get the formula 1 over f prime of f inverse of x. So we're going to use that formula for the next example. So let's look at example 1. Given f of 3 equals 5, and the derivative of f with respect to x at 3 equals 6, find the derivative of f inverse with respect to x at 5. So if we are given this information, one thing that I can take from this information is f inverse of 5 equals 3 from the given information. So I know that f inverse of 5 equals 3. Okay, so that's the first thing. They want us to find the derivative of f inverse with respect to x of 5. So using my formula I found over here, I would have 1 over f prime of f inverse of x, or instead of x, 5. This would give me 1 over f prime of 3. And it's told us right here the derivative of f prime of 3 is 6. So then my answer would just be 1/6. Let f be a function that is differentiable on the interval I. And if f has an inverse, function g, then g is differentiable at any x for which f prime of g of x does not equal 0. Moreover, g prime of x equals 1 over f prime of g of x, where f prime of g of x does not equal 0. And then Leibniz notation, dy dx equals 1 over dx dy, or dy dx times dx dy equals 1. Example 2, if f of x equals x squared, where x is greater than or equal to 0, compare the slope of f at x equals 2 and the slope of f inverse at x equals 4. So first, in order to find the slope, you need the derivative. So I'm given f of x equals x squared. So let's go ahead and find the derivative at 2. So I'd have f prime of x equals 2x. So f prime of 2 equals 2 times 2, which is 4. So we have 4. Then they want us to compare the slope of f inverse of x. So we need to find f inverse of x. If f of x is x squared, f inverse of x is the square root of x. And we're only doing this for greater than or equal to 0, so we don't need the negative. This is the same as x to the 1/2. To find my derivative of this, it would be 1/2 x to the negative 1/2, which is the same as 1 over 2 times the square root of x. I want to find this at 4. So f inverse of 4, the derivative of that would be 1 over 2 times the square root of 4, which equals 1 over 4. So what can you tell between the slope at 2 and the slope at 4? What are they compared to each other? Hopefully you said reciprocals. Let's look at example 3. Selected values of a strictly monotonic function g of x and its derivative g prime of x are shown on the table below. We need to find the derivative of g inverse of x at 1 and then the derivative of g inverse at -3. So let's start with A. We want to find the derivative of g inverse at 1. So that means we would have 1 over, using our formula we derived, g prime of g inverse of 1. Well, looking at our table, g inverse of 1 is -1 because it would be the x value. So this would be 1 over g prime of -1. And g prime of -1 is -1/5, so this would be 1 over -1/5, which equals 5. Let's go ahead and do B. Same process. We need to find the derivative of g inverse at 3. So it would be 1 over g prime of g inverse at 3. This would be 1 over g prime of, so I forgot my -3, so it should be -3. So this would be g prime of 4 because g of x is -3 here, so it would be 4. So g prime of 4. And this would be 1 over -2, so just -1/2. Example 4, the same thing. Selected values of a strictly monotonic function h of x and its derivative h prime of x are shown. Let f of x be the function such that f of x equals h inverse of x. Find f prime of -1 and f prime of 4. So since f of x equals h inverse of x, we can just use the formula again. So another way you could write f prime of x would be 1 over h prime h inverse of x for each of these. So with A, if I want to find f prime of -1, this would be 1 over h inverse, or h prime of h inverse of -1. Looking at my table, h inverse of -1 would be 0. So I'd have h prime of 0. Look at my table, h prime of 0 is 1/2. So this would become 1 over 1/2, which equals 2. With B, if I want to find f prime of 4, this would be 1 over h prime, h inverse of 4, or 1 over h inverse, h prime of. So I look over here. I need to find h inverse of 4. Here is 4. My inverse answer would be 2. So I need to find h prime of 2, which is 1/6. So this would be 1 over 1/6, which equals 6.